Welcome to Sacred Heart High School. So today we are going to learn Maths lesson number 8, variation. And in variation, we are going to learn direct variation, inverse variation, time, work and speed. Direct variation. When we talk about a direct variation, we are talking about a relationship where as x increases, y increases or decreases at a constant rate. That is direct variation between two quantities x and y. This statement can be written as x alpha y, that is, x is directly proportional to y, and it is written in the form of an equation x is equals to ky. Example, cost of groundnut is directly proportional to its weight. If cost of 5 kg groundnut is rupees 450, then find the cost of 1 quintal groundnut. 1 quintal is equals to 100 kg. Solution. Let the cost of groundnut be x and weight of groundnut be y. It is given that x varies directly as y. Therefore, x alpha y or x is equals to ky. It is given that when x is equals to 450, then y is equals to 5. Hence, we will find k, where x is equals to ky. Therefore, substituting the value of x and y in x is equals to ky, we have 450 equal to 5k. Therefore, k is equals to 450 upon 5. Therefore, k is equals to 90. That is the constant of variation. Therefore, equation of variation is x is equals to 90y. If y is equals to 100, x is equals to 90 into 100. That is equals to 9,000. Therefore, cost of 1 quintal groundnut is rupees 9,000. Inverse variation. Inverse is very similar to direct, but in an inverse relationship, as one value goes up, the other value goes down. If x and y are two quantities such that x into y is equals to constant, then there is inverse variation between x and y. X varies inversely as y and is written as x is inversely proportional to y. That is, x is equals to ky. Example, f is inversely proportional to d square. When d is equals to 5, f is equals to 18. Hence, if d is equals to 10, find f, and when f is equals to 50, find d. Solution, it's already given that f is inversely proportional to d square. Therefore, f is equals to k upon d square. Therefore, f into d square is equals to k. When d is equals to 5 and f is equals to 18, substituting the value of d and f in f into d square equal to k, we have 18 into 5 square, that is equals to k. Therefore, k is equals to 18 into 25, that is 450. And that's the constant of variation. So the question asked first is, if d is equals to 10, then find f. We know that f into d square is 450. Therefore, f into 10 the whole square is equals to 450. Therefore, f into 100 is equals to 450. Therefore, f is equals to 450 upon 100. that is 4.5. Second, if F is equals to 50, then find D. F into D square is equals to 450. Therefore, 50 into D square is equals to 450. Therefore, D square is equals to 450 upon 50. Therefore, D square is equals to 9. Therefore, we can say that D is equals to 3 or D is equals to minus 3. Time, work, speed. Example related to time taken to finish a job and the number of workers of inverse proportion. The time taken to cover a certain distance by a vehicle and its speed is related to variation. The examples related to time, work and speed are the examples of variation. Example: 15 women finished the work of harvesting a groundnut crop in 8 days. Find the number of women if the same job is to be completed in 6 days. Solution: the number of days required to finish a job is inversely proportional to the number of women employed. Therefore, number of days be D and number of women be N. D is inversely proportional to N. Therefore, D is equals to K upon N. Therefore, D into N is equals to K and K is constant. Now, if N is equals to 50, then D is equals to 8. Therefore, K is equals to D into N, that is equals to 15 into 8, that is equals to 120. Now let us find N when D is equals to 6. D into N is equals to K. Therefore, D into N is equals to 120. Therefore, 6 into N is equals to 120. Therefore, N is equals to 120 upon 6, that is equal to 20. Therefore, 20 women should be employed to finish the work in 6 days. Thank you.